When we trace the origins of modern science, the map usually starts in one of two places: the city-states of ancient Greece or the cobblestone streets of early modern Europe. We're taught that this is where astronomy and medicine first took root, but that narrative leaves a massive gap. By focusing heavily on the West, we skip over entire centuries where the scientific method was already thriving. Long before the European Renaissance, the Indian subcontinent experienced a golden age of rigorous empirical observation. Institutions like Nalanda University were hubs of physical, intellectual architecture, analyzing the natural world with staggering precision. The surviving proof of this era lies in two foundational texts. One mapped the mechanics of the solar system, and the other maps the human body. Decoding these manuscripts forces us to adjust our timeline. The practice of testing hypotheses and recording observable data was born much earlier and much further east than we typically acknowledge. In 499 CE, a 23-year-old prodigy named Aryabhata published a treatise that would define Indian astronomy. His work is so central to India's scientific heritage that his namesake satellite is printed right on the back of the 2-rupee note. Most of the world believed the stars actively rotated around a stationary Earth. Aryabhata argued that this was an optical illusion. He explained that just as a person in a moving boat sees the shore moving backward, we see the stationary stars moving westward because the Earth is spinning on its own axis. He applied the same spatial logic to eclipses. He dismissed the mythological ideas of celestial demons swallowing the sun, and instead correctly identified eclipses as geometric shadows cast by the Earth and the Moon. He calculated the length of the sidereal year, the exact time it takes the Earth to orbit the Sun relative to the fixed stars. His figure was 365 days, 6 hours, 12 minutes, and 30 seconds. That is within 3 minutes of the modern accepted value. He also calculated pi to 4 decimal places, arriving at 3.1416. Crucially, the specific Sanskrit word he used in his text means approaching, showing he recognized pi is an irrational number that can't be resolved into a simple fraction. To make these massive astronomical calculations possible, Aryabhata had to invent a new mathematical tool. He developed the concept of the jaya, or half-chord, which laid the bedrock for what we now know as trigonometry. Aryabhata mapped the solar system centuries before the invention of the telescope. He did it by building entirely new mathematical frameworks to describe the invisible mechanics of the universe. While Aryabhata was looking at the cosmos, another discipline in India was looking inward, applying that exactness to the human body on the surgical table. The text known as the Sushruta Samhita demanded that students actually observe the mechanics of the body. Rather than relying on abstract medical theories, surgeons were required to dissect corpses to understand anatomy firsthand. The training was intensely practical. Before making a single cut on a patient, students practiced their incisions on leather bags filled with fluid and learned to extract objects using watermelons and gourds. This hands-on approach resulted in a hyper-specific catalog of human anatomy. The text maps out exactly 300 individual bones, categorizing them by their specific locations and functions within the skeletal system. It also documents 1,120 different illnesses and provides the designs for specialized surgical instruments, from forceps to scalpels, tailored to specific operations. The pinnacle of this surgical precision was the invention of cheek flap rhinoplasty. To reconstruct a damaged nose, surgeons used a continuous flap of living skin from the cheek, rotating it over the nasal cavity while keeping the blood supply intact, a procedure structurally identical to modern plastic surgery. Whether they were calculating the geometry of an eclipse or rotating a skin graft, ancient Indian scholars were bound by a shared methodology, a demand for hands-on, verifiable data. This wealth of knowledge didn't stay confined to the subcontinent. By the 8th century, these mathematical and medical manuscripts were exported to Baghdad, where they were translated into Arabic and preserved during the Islamic Golden Age. You can literally track this geographic journey through our modern vocabulary. Aryabhata's Sanskrit word for the half-chord, jaya, was translated into Arabic as jiba. European translators later misread that as jibe, which means pocket or fold, and translated it into the Latin word sinus. Today, we call it the sine function. Sushruta's medical texts followed a similar path. His surgical techniques, especially the cheek flap rhinoplasty, slowly made making their way into Europe, directly influencing medical practices right up through the Renaissance. The everyday math students learn in high school and surgical procedures used in modern operating rooms carry the direct, hidden DNA of these ancient scholars. The history of human observation isn't a straight line drawn from Greece to Western Europe. It is a continuous, shared global endeavor.